Well, hi, good morning, and thanks for joining me here in my shop on the 28th day of July. And I'm going to start this video out a little different than other videos. I did a bunch of work on here, which you're not going to see on video. But what you are going to see is me try to sort out what has gone wrong since I did that work. So the last video ends with me vacuuming dust off of here. I turned down the volumes on my recording system while I did that so the vacuum wouldn't be too loud. And I then forgot to turn the volume back up and continued on doing work on the radio here. Like you can see some new capacitors installed here. There's actually 3 of them in here. 1, 2, 3. How come I think there was 4? How come I have it in my head? Yeah, 4. There's a 4th one. Not this orange one. The orange one was in here already, even though that looks like another replacement done by somebody else because it's not the right vintage. That's why I left this one alone. So let's take a little closer look here. So what has happened, what I've done, if you notice, all the replacements, and maybe you can't see this in the camera, but all these replacements have been done from the top of the board rather than the bottom. The bottom is actually blocked by the way the metal framework is under here. It's not easy to access parts from underneath. Some of them are completely hidden. So I chose to do these from the top, which is not too tough to do. Just trim out the old part and leave the leads protruding up through the board and then just solder to those leads, which is what I did. One. I had to put 2 in parallel here to get the right capacitance. Another little one down here and one here. I did 4 of them. Turn the set on, nothing happened. Now some of you are noticing this empty jack here. This is for the this is for the push buttons. Okay, which I went and got, and I had it plugged in there. First I operated the set without this and got nothing, and then I thought, well, maybe I have to have this plugged in to get the sound to come out. So I did that. No sound. Speaker here is hooked up via this very heavy wire. I checked this with a battery to make sure the speaker was working in that just by tapping a battery. Speaker's working, and then I'm just attaching it to the output transformer here. You can see the remnants of the original speaker leads and 2 black wires going here. So again, I'm just showing you what I did. If I put this here, switch the set on, absolutely nothing comes from the speaker. I put the speaker right up against my ear. I cannot hear a hiss, a hum, a click. Nothing whatsoever. Is completely dead. Now, all the capacitors I did are in the audio portion of the radio. What did I do wrong? That's the challenge today. I know one thing I did wrong. I did 4 capacitors and then tested the radio, and I really should do them one at a time. But I thought, what can go wrong here? And I'm still thinking exactly that. So I think we're going to start off with playing the radio just to see if overnight it fixed itself. Or maybe I'll encounter something else by doing that. By the way, if we just, for a minute here, have a look at the tuning situation. So this is set to medium wave. Look at that. Feels great. It goes all the way. No restriction. This is banged right up against the edge here, as if it's been pushed. But we'll just leave that alone. So later there's a procedure, I'm sure, for making sure the pointer's in the right spot. But anyway, the good news is pointer's working fine. That problem is resolved. Now, let's turn it on. See what comes out of the speaker. I'd be stunned if something comes out, but you really have to start again. Okay, and so we'll be on the AM speaker. We're on, let's turn it off to start with. just double check the offness. It's plugged in. Okay. Put the dim bulbs in. Should get full there. 122.3, and nothing happening here, of course. Now we're going to push this. There we go. I saw a little bit of light come out of this bulb here. Give it a moment. The eye comes on bright and quick there. I notice the eye doesn't respond, but we'll take a closer look at that, because this is a good giveaway for what may be wrong in the radio. Okay, let's give it full power here. Volume up. Now I'm going to do the dangerous thing of putting this right up against my ear, because if the radio suddenly comes on while I'm doing this, it's goodbye to my ear. So I'm listening now. There's absolutely nothing in this speaker. Nothing at all. And all the wires are hooked up. I double checked this. At this point, last time around, I checked this with a battery to make sure everything was working. It was. Zero sound. So that really indicates almost certainly no B plus going to the output tube, but I don't know. So what do we do next? Watch the magic eye and see if tuning causes a reaction in the magic eye at all. So, you know, this is starting to look, this is starting to look like a total loss of B plus in this radio, because it's silent. This isn't operating at all. In fact, I think the first time we operated this radio, this came out a little bit further. Wait a minute. How can you not? You can't light these up without some B plus. Okay, so, well, it's operating as if there is no B plus, but look. That's pretty mysterious stuff. I've done a good job here at making a puzzle. So how are we going to approach this? I think we'll do signal tracing. Should we do that? Why would I do that? This is not reacting at all. Let's try another band. Oh, I saw it jump. Oh, look at that. Wait a minute, I'm hearing something. It's not coming from the speaker. It's coming out of the transformer, or some other part is mechanically working like a speaker. So wait a second. Wait a second now. If this is making sound, then why isn't this making sound? Speaker wire. Let's check it again. Okay, so leave the volume right down. What did I just hear? Now, if you can hear that hiss, that's coming out of here somewhere. Not coming out of here. It's pretty convincing. Okay, so there's another output here for the smaller speakers. That's this one. It's just nothing. Nothing. Volume's down. Volume up. Nothing to do with the speaker. Let's do this. Why don't we stare at the schematic for a little bit? And just see if by some chance maybe I've done something stupid down here with this capacitor. Now that kind of silvery looking capacitor in there is a 1800 picofarad, and it's replacing this brown one, which I put where? I put here. Okay, this brown one clearly says 2 nanofarads. 2 nanofarads is 2,000 picofarads. Right? So putting an 1800 picofarad in there is as good as putting a 2000. This, by the way, tested perfectly fine. This actually showed no leakage, even at 300 volts across it. You know, I didn't have to replace this one, but I did. Just because I didn't put it on video. This one I also tested for leakage. It's completely leaky. Even at 50 volts it shows a lot of leaks. So no surprise, look at this thing. But this was a bit of a surprise to me. Nevertheless, we got nothing going here. So let's switch this off. We'll study the schematic a little bit, see if we can come up with a theory of failure here. Theory of failure. It doesn't involve me as the theory. Okay, take me a minute to get the schematic up here. Okay, so I just finished going over this whole schematic and then realized I didn't click record. So here we go again. This is my third journey through this. So here's the output area. I'm just going to highlight the curious things. Why are there so many speakers here? There's only 3 in my radio. Why are there so many shown? Because different radios use different combinations of these speakers, and they're all listed here. The Rigatti, the Parsifal, the Traviata, and the Phono Super. So I got the Traviata. It lists 3 speakers, 22, 25, 26, and that's this, 22, 25, 26. The rest of this does not exist. In fact, these speakers are electrostatic, and if you trace back, they look like they're connected in with the plate and the screen somehow. Somehow they're getting their high voltage to operate, but they don't exist in this radio. And these 3, if you notice, the wiring is shown with dotted lines. And I'm not exactly sure why, maybe to denote that this is a set of speakers. And maybe this is the other set, kind of like this. I don't know, I'm not going to look any closer. These are what we're worried about. Now look at the output transformer. You see a center tapped secondary. You can see a ground connection on one side here. If we look at this speaker gets its supply from this part of the output winding through this inductor. Now that makes sense because the inductor will restrict the higher frequencies. So you won't waste them on this speaker. You want the higher frequencies to go this way. But things get screwy after this. Totally screwy. So these speakers, if you look carefully, if they'd drawn this wire around the front, it'd be more apparent that the 2 wires have the same formation of wiring. They're hooked up the same way. Except this one has inductors. So in the cabinet, as you'll see in a few minutes, this is on the left side, this is on the right side, or other way around. Why would one of them have... And what are they restricting here? They're restricting the highs from this one. I wonder, you know what, maybe these aren't identical speakers. Maybe when I glanced at them I didn't notice them. One of them is a tweeter and one of them is a mid-range. It doesn't make sense because they're both mounted on the outsides of the cabinet. So you'd think they'd be doing the same duty. Maybe not. That's very odd. That's an odd, it would make it sound kind of weird, I think, having the treble come from the left and the mid-range come from the right. The lower sounds, you really can't tell where they're coming from, so you don't have to worry too much about that guy. So on the top of the output transformer, there were 3 wire terminals, or 3 terminals with wires from the speakers. One terminal had 2 black wires going to it. The other terminal had a yellow, I'm looking at it, and an orange each. A yellow and an orange. Right in the yellow was going down this way. It was as if it was from here, a solid wire to here. That makes more sense. That makes more sense to me. That means everything coming out of this output transformer would... So things get even weirder. So look at this point. Let's pretend this is the output point. And so the signal coming out of here wants to get back either in here or back in here. This side of the transformer is connected to nothing. These don't exist. So this winding is not even used in this radio, according to the schematic here. So this speaker, let's just take this one, is connected. What is going on? So you get well, now would this really work? So these speakers are essentially connected across this inductor. Across this inductor would be a reduced low frequency, and the high frequencies would be sitting here. That must be what's going on. So the through current is pumped through this speaker, and that's the lows. The highs get built up across here and are drawn off, so to speak, to go here. That's got to be how this works. And then they're coming along here. There's no restriction here, so all the highs come out of this one. But then there's a further restriction here. Let's look up here. So at the Traviata, that gives you the part numbers. Son of a gun. So 25 and 26 have exactly the same part number. Is it? Is that the same? Oh, I can't tell. Well, these might be different. Well, we'll look at the speakers and we'll know. Wait a minute, yeah, V22, yeah. They look the same, don't they? Okay, really a very unusual arrangement here. It's really kind of peeled my head apart trying to sort this out. But I think I got it now. I think I got what they're doing now. Yeah, let's look at the actual. So it's a good time. Good. It's a good thing I took 3 shots at this to get it. I think I got it. Hey, here's some voltages here. So on this, we should have found. Well, there's 2 listed. So AM and FM has different voltages. 250. I think that's it. I don't know what that says. 2 something 5. 225. I don't know. 245. I don't know. And down here, 225. Almost the same. 210, 245, I don't know. I thought these voltages were a little bit more different than that when I tested them, but look, here's another reading here. This is a critical one, 68 volts and 63 volts. Ooh, we gotta make that measurement at some point. Okay. Now, why? So only 2 terminals are used on this output transformer, and I was trying to use essentially 3. 2 sources and then a single return for the 2 sets. But that's not how this works at all. So the output comes out, goes across this coil. Okay, we can. So okay. So what if those black wires? So assuming the black wire is this wire, then it would look, but there's supposed to be an inductor. Is this inductor built into this transformer? No, I think this is on there. Okay, enough questions. Too many questions. Let's take a look and see what the speakers look like. Okay, so I have this propped up on my tube tester. That's why you can see the tube tester down here. So just ignore all that. We're concentrating on these speakers. So first of all, here's the wires I cut. It's an orange one and a yellow one and 2 blacks. The 2 blacks were connected together. They went to the top of that transformer, and these, the yellow and the orange, went to 2 separate terminals. My thinking was, obviously the black is the return and the yellow must be for this guy. Oh, that's interesting. I got them backwards in my head. And the orange comes to here. And then the orange is carried on. It's still orange all the way over to here. Voila. Very simple. So there's two outputs on the output transformer, one for this guy and another used for these. That makes perfect sense, but that's not the way it works at all. How does it really work? Well, let's start with this speaker. There's nothing going on up here. There's no coil or parts or anything. It's just clearly just a wire going up there, the yellow one. So now if we look at this speaker, it would almost have to be the case that this is in series with this. Because if I just hook up my bench speaker to where the yellow and the black wire are, I get nothing. Absolutely nothing comes out. How can that be? How can it be that nothing comes out? It only comes out between where the yellow wire and the red wire were connected. Then these black ones must be joined. They must be joined together. But that puts the voice coil of this right in series. Maybe it doesn't put it in series. It brings it over here where there's a big coil. This coil is connected right across the voice coil of this. There's no center tap or anything like that. So whatever comes over on this red and black wire meets up with a coil. Let's go through the coil to get back to this one. Oh my God, this is, the simplest thing, isn't it? But it isn't. Okay, let's look at the other one. So he's got a coil here, and he's got another coil you can't see back here. Two coils. So this is the two coil speaker. Two coil speaker, one coil across this one. These speakers, they look identical, don't they? They do look identical. These have to be identical. There's some numbers up on the top there. This is 470-00714, and this is 470-00714. 00714, 007, exactly the same. But they treat it differently. So maybe, just through componentry, one is made to be more trebly than the other one. Why would they ever do that? This just doesn't make any sense. It's basically a two-speaker system, a two-way speaker system. Wow. The problem here is I've got paradigm thinking, I think. Even that's a paradigm. Thinking I have paradigms is a paradigm. When I'm caught in it, I cannot break free. I must break free. Break. Hey, take a break. That's a good idea. I'm going to take a break. Okay, so I think I got this figured out. I think I'm correct in that this inductor is a majorly important part. This inductor is actually mounted on the back of this speaker. If you follow, you can imagine this inductor being slid down these lines. You can picture it coming all the way around until you can see it clearly is connected right around this, bypassing this speaker. So the low frequencies bypass, or the way I had put it, the high frequencies are sitting across this inductor, and then they're tapped off. It's the same story. These speakers are in absolute parallel. What is going on with these? The interesting thing about these two coils is there's two of them. As if they have to balance this out somehow, or they can't have it on one side with one coil. They need two coils to keep something in the middle. I don't know. I don't know what's going on with this. I really don't. So this would restrict highs and allow lows. And this one is unrestricted for whatever comes across this coil. I don't get it. Okay, so I don't have to get it. So now the black wires. So the confusing thing is there are 3 terminals on the top of this output transformer with connections, but there's only 2 terminals being used on the schematic. I gotta guess the 3rd terminal is just a joint terminal, just for joining things. The spare terminal. The black wire comes off of here, travels to this speaker where it encounters this coil over here, and then travels back on the black wire over to this speaker, making it look like these speakers are kind of in series when they really aren't in series, but it kind of looks that way. All because of this inductor. And we just have to assume this was done for some reason. I don't know what the reason is, but you know what? I know what this is. They put these in here. They don't do anything except drive engineers and other companies nuts while they try to examine, hey, what are these guys up to over there in Nordmende? You see this arrangement? What's going on? And burn up hours trying to figure it out, and it's a trick. It's like reverse spying, like a Trojan horse into some other guy's lab. Can't be the case. Okay, stared the heck out of this. So, quite clearly, just 2 terminals. I should carry on. I should be free to carry on with the bench speaker hooked up to where the orange and the yellow went. And that solves this whole issue of what is going on here, sort of. Okay, so the conclusion after all that is capacitors are okay, everything's okay, and now I'm okay too. So let's play this radio and find out if I really need this to be plugged in to make the radio work. Take this off its stand here. Okay. Play it this way. Medium wave. Volume down a bit. Dim bulbs in. A long journey to find out nothing's wrong except what's in my head. I think that's an awful lot of what this kind of work is all about, is straightening out what's in your head. You come into it with notions about what is probably the case with the radio, like for instance the speakers. I have notions about that. Causes paradigm thinking. Get stuck in it. Can't break free. Finally you break free. Great. I'm broken free. Now that's a lot of talk. We don't hear a thing because I didn't hook this up. So we go, for the sake of running one speaker, no coils, no tone control, no crossover. That's what I really should say. I should get on there. Hot diggity dog. Volume's still kind of low. I got this full. Let's tune around. Hey, this is the first time we've been able to tune this. Not very impressive. I want to find out if I need this. Turn down the volume, pull this out. And the answer is yes. Now, radio's on. Put this back in. Set this back here. Tubes will keep it nice and warm. Give me a sit there, please. There. Something happening with the antenna. This must be the AM side here. This might be something else. I don't know. So where are we tuning? We're tuning around medium wave. We should get something right around here. Now, unfortunately, I don't want to rotate this whole thing. I don't have it on my turntable. Nothing. getting louder as we go down, but that doesn't mean much. Nothing up here to here. No action on here. Try shortwave now for the first time. Okay, I've got my shortwave external antenna here. Where's it going on the back? I got the back handy. Let's take a look. Let's see. Speaker. FM, the top, antenna. Okay. I'm gonna clip onto the terminal. Let me tap it. Yeah, that sounds like something happening there. Yikes. Around the other side of this. I have the feeling my antenna's... That's quieter. I think I have to go through a switch. Where are we tuning here? So we're on the K band. 6 megahertz, that's way too low. 6, 10, 12. I better go through a switch. Okay, so I'm just going to run off and I'll be back in 13.65 seconds. Okay. Pretty noisy stuff. Just noise. Fixed it! Medium. I thought it was on shortwave. That's better. There we are. Maybe because I put this clip on. Wait a minute, I'm hooked up to the shortwave antenna, but it probably doubles for the AM band. Let's see, let's go back here and find out. Sounds like the radio retuned it. If I rotated this properly, probably the signal would come in loud and clear. And all of the stations I normally get here in my house are all roughly in the same direction. So this is probably not rotated correctly. So I'm not going to get... Well, they're there. That's good. That's very, very good. How about this guy? Is this guy moving along? It's a noise signal, but see, that's an unmodulated noise. Where the stations go here. Not much action there. Volume's up a long ways. There's not much more left of it. Still have weak output. Okay, shortwave. K-band. Okay, we're going to have to clean the switches here. Full volume. Should get something down around here. Ooh, what was that? That would make you think there's something wrong with the radio, wouldn't it? Wait. It's odd. Heard stuff like that before. Two spots. Come on. Doesn't want to pick anything up. Okay. Hey, let's listen to FM. After all this, we might as well. FM needed some kind of an FM antenna. Something anyway. Before we try this. Okay. So this is just a vertical wire. Just a vertical wire. FM. Full blast. So notice the different pointers moving now.
Turning Point presents the Jeremiah Study Bible. Jumpstart your Bible study with more than 8,000 study notes from Dr. Jeremiah.
Dr. Jeremiah.
For you. Available in the new
Very weak. The light doesn't help much down here.
How often do you come up to the Piccinini Center?
30 years.
Every day?
No, every day one night at a time. Because I don't got nothing to do. Oh, play cards and talk with friends.
I have no idea what that is. Well, the good news is it works. The bad news is no volume. Is it because of the way I got the speaker hooked up? No, I don't think so. I think there's definite big time weakness here. Probably not in the audio circuits. I've replaced capacitors there, but it hasn't had any effect yet. FM low and medium wave low. It's all low. So there we go. Anyway, what did I succeed in doing today? Found out how the speakers work. Yeah, that's really a miracle. You know, one of the things I really like about this work is puzzling over things like this. I don't like jumping to the internet and asking the internet, you know, for my answers. I like discovering them myself. This to me is the fun part of this. So I replaced the capacitors and the radio didn't work. And I was kind of excited about that, believe it or not, because I'm a little loopy. But also, that really is where I have a lot of fun, trying to sort things out, trying to figure them out. That's the part I like. Okay, so I hope you liked it. I hope you liked it too. What are we left with? Back to doing capacitors. Do some more along the way. Won't worry about the low volume until all that is done. At that point, if the volume is still low, well, then we'll have to worry about it. Up until then, we'll just assume it's a dead capacitor in there somewhere doing something it shouldn't do, or not doing something it should. Thanks a lot for watching. We have another nice day of weather outside today. A little cooler now. So that's where I'm heading. My cats are already out there waiting for me. So thanks a lot for watching, and see you on the next video.